The population of capital N of the United States depends on the date d. That is, the function n equals n of d is a function of d. So looking at this table, identify the dependent variable and the independent variable. So in this case, the independent variable is d in years, and dependent variable is n of d, which is population. Population in millions. What was the increase in the population from 1970 to 1980? So from here to here, what's the population increase? We just look at these two numbers and know we find a difference, right? So when we find the increase, essentially we're finding the decrease here. Difference. So I'll do population at 1980 minus 203.98, which is population at 1970. If we subtract these two numbers, we get 23.25. Again, the unit is in millions. So from 1970 to 1980, we have a population increase of 23.25 millions. Compute the average rate of change from 1970 to 1980. So here is asking us to find the average rate of change of population from 1970 to 1980. So when we find the average rate of change of anything, the rate of change is still with two quantities, relationship between two quantities. In this case, population over date in years, right? So years. So we do change in population. We can write it as change in population. This delta triangle means change, or change in over change in date, which you can find change in population. So what we can do is we can actually write the year, which is input, 1980, minus 1970 over 1980 minus 1970. So on the numerator here, this is representing population at 1980, population at 1970, which we can find by using the table here. 227.23 for population at 1980, minus population here, 203.98, over, this is 10. So if you subtract, we get 10. So then we get 23.25 over 10, which is 2.325 millions per year. So in average, each year there's increase of 2.325 million between 1970 and 1980. So how can we use the estimate of population of 1973 using the information above? So we started 1973. Well, we started 1970. In 1970, and from 1970, the population in average increased 2.325 each year, million each year. So we do 1970 plus 3 years, and each year there's increase of 2.325 million. So for 3 years, each year increase was this. So we do 3 times that. So then we get 19. Oops, actually, let me write it back. This is actually, I should write as population at 1970, which is 203.98 plus this number. Then we get 203.98 plus this number right here. If I do that, get 5, 7, 9, 6. So 6.975. If we add these two numbers, we get 210, 9. Let me see. Let me actually write it down on the side. So 20398 plus 6.975. Okay, 5, 5, 9, 0, 10, 2. So our population, this is the estimate. We can estimate that population in 1973 is this 210.955 million. So using the average change each year between 1970 and 1980, we're able to estimate this population in 1970. A rock dropped near the surface of the Earth travels distance function d of t equals 16t square feet during the first t seconds of the fall. What is the average velocity from the time t to time 3? So we have distance function, and velocity is distance relating to time. So average velocity here is, again, change in distance over change in time. This triangle, we call it delta, but it means change in. Instead of writing the word change in, we just write delta. And we can find the change or difference by subtracting in this case. So time at 3 seconds, at 2 seconds distance, divided by time, 3 seconds, 2 seconds. So this tells us difference in that distance, this tells us difference in time. So if we compute those and divide, then it gives us average velocity between 2 and 3 seconds. So let's find that. So then we plug 3 here, we get 16, 3 square minus 16, 2 square over 3 minus 2 is just 1. So let's go to the next line. I have 16 times 9 minus 16 times 4 over 1. 16 times 9, let's see, what is that? 6, 1, 146. Oops, sorry, I meant to write 144. 54, 90, 144. So 144 minus 16 times 4 is 64 over 1 gives us 80. So this is 80 feet per second, right? 80 feet per second. This is, again, a lot of times we also write feet per second like this. So in average, from 2 to 3 seconds in this interval, for each second, the average speed was 80 feet per second. A rock dropped near the surface of the Earth travels dt equals 16 t square feet during the first t seconds of fall. What is the average velocity of the time interval 2 to 2 plus h? So the idea for average velocity is always a quantity over change in quantity over another quantity. Change in output quantity over input quantity, or change in dependent variable over change in independent variable. So here, we're to find change in distance, which we're plugging in 2 plus h as one time and 2 as another time. So 2 plus h just means the time after 2 seconds, because h a lot of times positive. And it could be negative too, because we could also find the time between 2 and maybe 1 second. So we're finding generic average rate of change focusing at 2 seconds, like this. So then we plug 2 plus h to here. We'll get 16 2 plus h square minus 16 times 2 square over, this 2 cancel out, so we only have h left in the denominator. So then let's simplify. We have 16 times, we FOIL this, we get 4 plus 4h plus h square minus 16 times 4 over h. And we distribute this right here. We'll get 16 times 4. Let me actually write that, which is 64 plus 64h plus 16h squared minus 64 over h. And we see here that this 64, they cancel out. So only thing we have left here is 64, 64h plus 16h squared over h, which we can cancel out. Okay, there's few ways to do it. We can factor h out like this. And now we can cancel this h out for a numerator and denominator, because now h is multiplied to this entire parenthesis right here. So then we have 64 plus 16h. So this represents average rate change between 2 and 2 plus h seconds, whatever the h is. So if you want to find average change between 2 and 3 seconds, h would be 1, right? If we want to find between 2 and 3 seconds, then h would be 1. So we plug 1 here, then it will give us average speed. If you want to find between 2 and 10 seconds, then h would be 8. And we plug 8 here, then will give us the average h in between 2 and 10 seconds. So this is more generic average change between 2 and another time. The time increase from 2 or time decrease from 2, which is h. Find the average rate of change of the function f of x equals x squared minus 3x plus 2 on the interval 1, 4. 1 and 4, between 1 and 4. So these are x values only. So finding average rate of change, the meaning is only change in f over change in x. But graphically, this also means finding slope between these 2 points on this graph. So that's what we're doing graphically. So we do f of 4 minus f of 1 over 4 minus 1, which we're, again, doing rise over 1. And we don't have to graph this to know the slope. But if let me just sketch real quick. If this graph, let me see, maybe look something like this, let's say, and we're finding between 1 and 4. So here's 1, maybe here, 4 somewhere here. We're finding slope of this line, slope of this straight line, which represents average rate of change between these 2 points. So graphically, that's what we're doing. But we don't always have to know the graph to find the slope or average rate of change, because we can just apply this right here. So let's plug 4 in here first. F of 4, 4 squared minus 3 times 4 plus 2, entire thing in parentheses, minus plug 1 in, 1 squared minus 3 times 1 plus 2, over 3. So then that's just simplifying. We have 16 minus 12 plus 2 minus 1 minus 3 plus 2 over 3. Now this right here is 4, 6 minus, this is negative 2, 2, so it's 0 actually over 3. So then we get 2. So average rate change between 1 and 4 is 2. Whatever, they don't give the unit here, but essentially it'll be unit per unit. Unit for the function, unit for the x value. Find the average rate of change of function x squared minus x plus 4, x squared minus x plus 4 from x to x plus h. Now here x to x plus h is, so they're not giving a specific interval. They're just they want us to find average rate change in general from a point to another point, x and x plus h. This is also known as difference quotient. So what we are doing f change in f over change in x, but we're plugging in x plus h, subtract f of x, over x plus h minus x, change in input variable. But then this actually simplifies in the denominator. Denominator is just h because this x and x cancels out. So this is known, name for this is difference quotient. Difference quotient. And difference quotient represents average rate of change between 2 points. It also represents slope of a line between 2 points, which is also known as a secant line. So if I have a line like here, this line is cosecant, this line, straight line is cosecant, and we're finding slope of this line. And we can find slope of this line by focusing these 2 points, like rise over run. And that's what we're essentially doing here. So let's compute this. So first plug x plus h to here for this first part. So we have x plus h squared minus x plus h plus 4. So this entire thing is just f of x plus h. I plug x plus h as input. Minus f of x. Just copy f of x given the function. Oops. X squared minus x plus 4. Entire thing over h. So after this, we simplify. We multiply these out. We get x squared plus 2xh plus h squared. Distribute the h, negative minus x minus h plus 4. Distribute minus sign here. Minus x squared plus x minus 4 over h. So then collect like terms. This x squared minus x squared cancels out. Minus x plus x cancels out. Positive 4, negative 4 cancels out. So only thing we have left with is, let me see, this one, this one, this one on the numerator, and of course denominator h. So we have 2xh plus h squared minus h over h. And we can simplify this. We can factor h out in the numerator. Then now we can cancel this h out like this. So 2x plus h minus 1 represents average rate change of this function between any 2 points, between x and x plus h. So if I want to find average rate change between, let's say, 3 and 7, x will be 3, and h will be 4. So I plug 3 here, I plug 4 here, for example. Then I can find specific average rate change. But this represents general average rate change between any 2 points. For average rate change, we always need 2 points or 2 time interval. Compute the difference quotient of function negative 2 over x plus 1. So let's look at this. So difference quotient is f of x plus h minus f of x over h. And difference quotient represents average rate of change between 2 points. In this case, the 2 points are not specified. 2 points are just x and x plus h. So when we do this, we can rewrite this using this function right here. And if that's too much in the beginning, we can always write x plus h separately first and then combine into one fraction. So here I'm plugging x plus h instead of x as an input here. So x plus h plus 1. So if I'm combining to here, I can write negative 2 over x plus h plus 1 minus negative 2 over x plus 1, which is the f of x, given right here. Divide by h. So this is the difference quotient form, which is in the beginning. Now we just have to simplify. So this is the difference quotient using this function. So now let's simplify. So first, minus, we can put positive. So we have negative 2 over x plus h plus 1 plus 2 over x plus 1. Entire thing over h. Now here, we need to add these two fractions. When we want to add or combine two fractions, we need to have a common denominator. So in order to have a common denominator, here I'm going to multiply x plus 1 over x plus 1, which is from right here. And on the right side, I'm going to multiply x plus h plus 1 over x plus h plus 1, which is from right here. We need to multiply both numerator and denominator because then we're essentially multiplying 1. So we're not changing the quantity. We're only changing how it looks. So let's do this. The next line. Now we have a long fraction h in the bottom. But in here, the denominator is just x plus h plus 1 multiplied by x plus 1. They're common denominator now. This portion, this right here, is common denominator. Therefore, we only need to write it only once. So, in the numerator, we have negative 2x plus 1 times x plus 1 plus 2 times x plus h plus 1, like this. Equals, now we need to distribute this like here. Then I have negative 2x minus 2 plus 2x plus 2h plus 2 over, this one we can leave it like this. No need to multiply out here. Entire thing over h. So then we can collect like terms. These will cancel out. Negative 2x and positive 2x. Negative 2 and positive 2 cancels out. So what we have left in the top function is 2h over x plus h plus 1 times x plus 1, entire thing over h. Now this dividing by h, we can think as dividing by 1 over h over 1, h over 1, which is same thing as multiplying by the reciprocal of h over 1. So like this, and we multiply by reciprocal of h over 1, which is 1 over h. And then this h cancels out. So what we have left is 2 over x plus h plus 1 times x plus 1. So this here represents average rate of change of this function between any 2 points, x and x plus h. Compute the difference quotient of this function, negative 2x squared plus x. So difference quotient is this, f of x plus h minus f of x over h. And it's very important to know what this is. But you need to know the meaning of this. This means average rate of change between x and x plus h. So here I can write x plus h, which is negative 2x plus h entire thing squared plus x plus h. So then I need to put this right in this position. So let me do that in the next line. I have negative 2x plus h squared plus x plus h. So this entire thing is expression. This expression is f of x plus h. Minus f of x. F of x is just given right here. Just copy that. Entire thing over h. So then let's multiply these out. We get negative 2x squared plus 2xh plus h squared plus x plus h. Distribute the negative sign. We have positive 2x squared minus x. Entire thing over h. So on the next line, we have to distribute this -2. So we have -2x squared minus 4xh minus 2h squared plus x plus h plus 2x squared minus x. The entire thing over h. So we can collect like terms. You see that minus -2x squared, positive 2x cancels out. Positive x and negative x cancels out. So what we have left with is -4xh minus 2h squared plus h, entire thing over h. So then we can simplify, we can factor h out on the numerator because each term has h, 1h. Like this, entire thing over h. And this h cancels out. So average rate of change or difference quotient is -4x minus 2h plus 1. So this is a difference quotient for this function right here, which also, the meaning of this, it represents average rate of change between 2 points.